Hello everyone, welcome back to our channel for Principal Software Engineer. Today we're gonna start our first exercise in this first lab of CSAPP. If you don't know what this book is or what these projects are about, please check out our previous intro video, which I will link in the description below this video. Um, the first lab is called datalab, which is listed in as the first lab in the official website. If you don't know how to download and how to set up your environment in order to do this project, please check out our another video, which is specific about environment setup. I will also link that video to the description of this video below. Cool. Okay. With that, let's take a look at the data lab project here. So here I have my terminal open. This is the data lab project files. So on the left side, I have the data lab directory open. Here are all the files. We only need to edit this bits.c. So on the right side, I have this bits.c file open. Here are all the functions we need to implement. We have 15 functions to implement in total. So there are 5 of them about bits manipulation, 7 of them about integer arithmetic, and then 3 of them about floating point operations. We'll start with the first one in this video. Okay, let's take a look at the first question, BitAnd. Here I have the problem description copied from the source file, so essentially the same description here. The question is about given two integer inputs and the return integer that is the result of bit level AND of the two inputs here. If there's no strings attached, then in normal program in order to do this, we just need to return x and y like this, and then that's it. But the requirement here is only using bit level NOT and bit level OR to return the same result. How to do that? Well, presently, I think the most intuitive way of thinking about this is try to describe this logic using a everyday life language here. Imagine x and y they are not bits; they are just to any of the physical objects here. Let's say I have a statement 1 saying, hey, I have a object x and I have object y. What make this statement not true, right? So let's say if I want to find an equivalent way of saying it's not true that I have x and I have y, right? This is the same as saying I either don't have x or I don't have y. Okay, so please take a look at this. So I'm essentially saying the statement 1 and the statement 2 are the same, right? Think about it and to see whether you agree with me on this one. Right, so if you agree with this, then it's easy, right? So we just need to replace this description of NOT and with the real bit level operators here. So this is essentially saying not x and y is equal to not x or not y, right? And this is then the last step is even easier to just move this not operator from the left side to the right side. Essentially, we're gonna have x and y equal to not x or not y. Okay, here the left side is essentially what we want here, bit level AND. Right side is also bit level AND, but only using bit level NOT and bit level OR operation here, right? Let's try out in the real code. So, okay, not X, and not Y. Okay, let's save this and try to compile it. Make B test. Cool. And then let's test the B test specific function. We want to test the specific function of the BitAnd, so I'm using this -f. Okay, it passed all the test and it's giving me full points. If you want to try out some other examples here, you can say -1 using the same example 6 and 5, -2, 5. This means like the first parameter passing as 6, second one, first argument passing as 6, and second argument passing as 5. If we do this, this B test will only run this specific test case for these two inputs, and now it's comparing the with the correct implementation, and they give the same result. So they are giving me the full points. The other thing, as I mentioned before in the setup video, is we should use the DLC to check the syntactic correctness of this solution to see whether we are using illegal operators or are we using more operators than allowed. So we can use -e to see it's C. Cool. So you can see the first operator we are using, first function we are using 4 operators, which is less than 8. Then with both of these two pass, we get this question right here. Pretty simple, right? It's only one line solution. This is really just a warm-up for all the remaining questions. Before we wrap up this question, another quick comment is, so the process of deriving this conclusion, let's say is number 3, like the process for deriving this number 3 conclusion from the equivalence of statement 1 and statement 2, this process does not only apply to bit level operation, it also apply to just a general general variable level logical operation here. What I mean by that is this statement number 4 also is true. So x and y is equal to not x or not y on the variable level rather than on bit level. Another thing to open question to ask is like, what if I have the input is actually 3 variables rather than 2 arguments? How to solve this? Should we use the same approach here? I will leave that to you as well. Cool. With that, let's wrap up the first question and move on to the next one. I'll see you in the next video.